the whole world at our feet, watching seasons change. Our roads were lined with adventure, mountains in the way couldn't keep us from the sea. Here we stand open arms. This is home where we are, ever strong in the world that we made. I still hear you in the breeze, see your shadow
Hello and good evening, everyone. I guess there's no such word as evening. Okay, let's see if I can see myself and hear myself on YouTube, and if I can, we can get going for tonight. Perfect, I can, so hello again, and welcome to my, well, weekly live stream. I would like to say that I do have a live stream every week, but as you know, I had to cancel last week on a short notice. I apologize for that. I try to not cancel, but yeah, sometimes, additional meetings, and I don't really have any luck on, I guess, making them every week, but I'll try to. Anyway, so today's topic is going to be blind return-oriented programming, which is, I guess, a really amazing and really cool modification to return-oriented programming, which by itself is really awesome and amazing technique. I really like it, in all honesty. So I never done it. I never done Blind ROP until yesterday evening, when I actually did read the paper. Again, I did read the paper. This is this paper, Hacking Blind. Oh, I'm sorry. I'm going to do a horizontal flip on. Yeah, here we go. Yeah, Hacking Blind is the title of this paper by these authors. And I'm going to give you a link in a second to this paper. This is basically the, the Blind ROP paper which began the whole idea. And I guess the technique itself is rather simple. If you've done any return-oriented programming and you've done any remote exploit debugging, then the techniques used here will be familiar to you. That being said, in the paper they have some really cool optimizations. I'm probably not going to go into them, but and they also added a structure on how to find some gadgets blindly. So I really recommend reading it. Again, I am going to give you a link in a second. So that's what we are going to do tonight. We are going to basically, you are going to watch me trying to do blind return-oriented programming. I did have an attempt on it, I guess, so like yesterday evening. So yeah, I should be able to show something. Cool. So today's moderator is KrzaQ. His nickname is here. If you have any questions at any time, then please do let him know, and he will let me know so I can answer them. Yeah. Now let's move over here. Perfect. Let's start with, I guess, the usual stuff, which is, this is KrzaQ's blog. It's dev.krzaq.cc, and if you're interested in C++, then you should totally check it out. He does post in English again, which is awesome. Yes, so check it out. I'm going to give you links here and there, as in on the YouTube chat and our IRC. Okay. Now, as usual, I would like to recommend Live Overflow's channel. Live Overflow streams about, well, actually make videos about security stuff, low-level security stuff usually. It's really awesome. I totally recommend it. And I also, I think, saw his nickname on the chat today. Hi, Live Overflow. Another streamer on CTF and security-related stuff is MormosCTF. He actually streams in the like US-ish time zone, so it's usually late at night for me, but it's awesome. Anyway, I totally recommend it, and check it out. And there are also, the archived videos, so you don't have to stay up night, you can always watch it later. Same with, I guess, my videos for other time zones. Now, for the usual music stuff, I would like to thank Nervous Test Pilot for his music, for allowing me to use his music, and also TheFatRat, which I started using today. I did use the Monody from him. His music is actually partly available for free usage on videos, which is amazing, and I think some songs are even open sourced to some level, so that's actually really awesome. Now, I would like to recommend, I am actually going to give you links to both Nervous Test Pilot and TheFatRat, because why not? Okay, and yeah, Mormos as well, and Live Overflow. Okay, perfect. Now, I did receive a link to a series of blog posts about reverse engineering Pawn Adventure 3. Pawn Adventure 3, if you're a CTF player, like an old-time CTF player, you will know what this is. This is basically an MMORPG game developed solely for the purpose of CTF competitions, which means it's an MMORPG game. The Pawn Adventures 2 was on Unity, Pawn Adventures 3 was on Unreal Engine, and they are, well, basically on the CTF, which was called Ghost in the Shell code, you get to hack them. Now, Antonin, if I got the name correctly, I am terrible with names, I apologize, created a series of blog posts about reverse engineering it and reverse engineering the protocol and the binary and so on and so on. Is actually, like, if we go into the details, the blog posts are rather verbose, and the series has quite a lot of articles in it, so I totally recommend checking it out. It looks really cool, especially if you're just like, well, even if you're already started with CTFs, it's totally worth checking out. So I'm going to give you a link again on the chats. Here we go. And yes, and this brings us to another topic, which is, oh, doesn't this work? Perfect. Which is the missions. So the last mission was actually solved only by 2 people, and that's because I am not a nice person, I guess. I made a plot twist. So it's like this. You get a zip file, and the zip file had only 2 selected bytes in the header removed. Like, they were zeroed. Actually, they weren't, like, you know, like, removed totally, but there was 0 bytes written there instead. So you get a zip file and 2 bytes removed, and the idea was to basically unpack it, right? But as you can see, the challenge had like difficulty 6, so that's quite a little more than you would expect. And I think I also did, yes, I did also say that there is a plot twist, and expect the unexpected. So I made a certain plot twist. I don't know if the people who actually solved it did notice it, because it kinda depended on your approach, but yeah, let's get into it. What was the idea? So actually, the removed, if you open the file in Hex Workshop, this is a screenshot from Hex Workshop, then you would notice that basically the compression method in both the local file header and the central directory header of the zip file was set to 0, but the compressed size and uncompressed size, these 2 fields, differed, which means that, well, it was compressed, but why was the compression set to 0, which means stored, which means not compressed? Well, because that's exactly the byte which was zeroed here and in the other header. So what you had to do is you had to basically correct this and job done, right? Now, this isn't fully true. So it's like this. The zip compression, okay, let's make this window a little smaller so I guess you can see the whole slide. I try to make the slides, well, compatible with my layout, but that doesn't always work. Here are the compression methods which are usually used in zip. Now, usually the most popular is deflate. There is also store, which means no compression, shrink, reduce, implode. There was also like a joking compression called, I think, explode, or inflate, which just like, I think explode, which just, it didn't compress, it did the opposite, it exploded the data. Anyway, it was just a joke. I think it was described in some RFC or some extension, but whatever. And also bzip2, LZMA, which is used in 7-zip, which you might know, Wavepack, which I have no idea what is it, and ppmd. And, well, you would expect I used deflate, right? And I didn't. I actually used ppmd, which might have surprised some people. And so the idea to solve this task was actually to go one by one by each compression, set it, and try to find the client which actually unpacks it. Now, WinZip totally handles, I think, most of them, or if not all of them. Probably 7-zip also handles most of them. And yeah, 2 people got it right. The second one was ABC, who did write a small description, and actually he said that he changed the method to shrunk and it worked, which I guess he used a client which corrected or detected automatically, but it's not really shrunk. So yeah, well done. Again, as I said, depending on the way it was used, it was approached, the task could be either easy or a little harder. Gurali was the person who solved it as the first one, and the secret password, as said, is my name is Bond, James Bond. Yeah, I guess you could guess this password. This is also the part of the password to the line below. So congratulations, and the mission number 8 will be today after the live stream. It's a little easier without plot twists this time. Cool. So let's move to hacking blind. I guess you already get the link on IRC. I am going to give you the link a second time anyway. Now, I am not going to go through this paper, but I totally recommend you read it if you're interested in blind return-oriented programming. If you don't know what return-oriented programming is at all, then you're going to have a hard time today. I apologize. I had already a live stream about return-oriented programming some time ago, and I guess you can just look for it, or if you look for return-oriented return-oriented exploitation, you can actually, I think, find my blog somewhere with my tutorial, which is just another tutorial on ROP. I'm going to give you a link anyway. So yeah, today I will assume that you actually know ROP, and I will base on that. Now, is my... Okay. Okay, I guess there are two questions, so let's do that. Is binary pawning part of my daily work, or what does one do at Google Security? It's not part of my daily work. I do it from time to time, mostly on CTFs, in all honesty. Sometimes if you need to actually prove something is exploitable to give some more incentive for the developer to actually fix it, but that's about it. And what I usually do is I usually do code reviews, coding a fuzzer, or I'm actually a manager as well. Do you have a plan for a long stream someday, like 2-3 hours at least? Yes, I do have a plan. I have absolutely no idea when. Would you post your Vim config? My Vim config is on my GitHub. If you go in the... Actually, I'm going to show you. I'm going to give you a link because it's easy for the Polish channel, because it's actually on my GitHub related to my Polish channel, which is this stream. You go here, there's a section called inne, which actually means other stuff, and it's here. So I am going to give you a link as well. And one more question, do I prefer tea or yerba mate? I do prefer tea. I tried yerba mate. I think it's an acquired taste, which I didn't acquire yet. Normal tea. Perfect. So I'm going to show you now the binary which we are going to exploit. And that was actually a joke. I am not going to show you because we don't know. And that's the whole problem with return-oriented programming, is that you don't get the binary. You have to exploit something which you know that there is probably a bug, right? But you don't get to see it. Let me just double check that I have my fonts correctly set. Yes, I do. So why isn't this rotating? This should be rotating. I don't know why this isn't rotating, but okay, whatever. So I do have a small application. Okay, so here's what I know about the tasks, which I guess we can assume that the attacker might know or might guess. First of all, I did intend the task to be super entry level, which means half of the techniques described in the paper, like for example bypassing the stack cookie, which, well, it wasn't really described in the paper, it was mentioned in the paper, or getting some data of the stack to get the address, like return address, to bypass ASLR. I decided not to play with it. I know how to do it. I think I done already a stream on the cookies, or I can do one, and same with ASLR. So I wanted to focus on the blind part of the ROP there. So my binary was compiled without like position independent executable, and ASLR was disabled whatsoever for the operating system. And I also compiled it without any cookies, and so it's just like a plain vanilla binary, but NX was enabled, so I couldn't execute code from the stack. So that's one thing, and the other thing, this document, the paper actually describes a method to use the gotplt, which is, the import table. And my binary is actually statically linked, which means there is probably no gotplt, or it's not used in the similar way as the paper, so I will deviate therefore from the paper. The rest of the things, I guess we can just check out. Yeah. There's a quick question. What operating system would I recommend for C development, considering latest NSA disclosure? I've heard about Ubuntu backdoor, so it made my choice difficult. I didn't read about the latest NSA disclosure. I guess I need to. Well, I personally use Windows. I mean, everything is backdoored anyway, so why panic, right? Yeah, I guess it's a personal choice in the end. It's not like anyone reviewed all of the code or spotted all of the bugs in everything, right? Okay, I wanted to mention one more thing. So actually, why is Blind ROP important? We have the binaries for most of the stuff, but when is it like really important? So the OpenBSD developers actually implemented a really cool feature, which was discussed, I guess, for a couple of years now as the next level of ASLR. In their kernel, what they did is that at each reboot, the kernel actually is relinked randomly, which means, when you have a huge code base, then you have a lot of functions and object files, or actually like whole compilation units and object files, and then you link them together to form one executable. Now, what they did is that they are linking the object files into the kernel executable every time the operating system is rebooted. Now, and I think at updates and some other stuff, moments as well. Anyway, and they do it in random order, which means the compilation units or the functions are actually placed in the kernel in random order, which means that even if you take the stock kernel, it's not going to give you anything for return-oriented programming. You do have to leak the binary, or you have to use the blind ROP technique. Again, in the blind ROP technique, usually what you do is you don't want to run a shell. You want to leak the binary, because when you leak the binary, you remove the blind part. You're no longer doing anything blind. You just do a normal ROP. So okay, now again, I have a service running. No, I'm not going to SSH. I'm going to show you the binary. It's on a virtual machine on Ubuntu. Okay, yeah. And this is what happens. It shows me the address. Again, ASLR is disabled. I could just have guessed this address. But I decided, why not? To make it easy for myself, especially that this was my first exploitation of blind ROP. Then it asks for data size, and you actually put, for example, 4 there. And, well, you have to give it 4 bytes of data now, so AAA. And it's actually an echo service, which means it just repeats whatever I have written, and that's it, right? So, yeah. First, we need to find the bug. Well, there is 2 input fields, right? One is for the number, and the other is for whatever amount of data we give it. So let's give it a rather large amount of data, for example, 128, which isn't super large, but that should be enough. I'm going to, do this. And you can notice the difference. It did echo it. It didn't echo everything, because I probably put here more than 128 bytes, right? But being said, it didn't echo done, which means it probably crashed. Probably there is a buffer overflow. Obviously, I know there is a buffer overflow here. So, well, first I need to figure out where is the boundary of this buffer overflow. When does it begin? I can do it in 2 ways, I guess. One way is just to test random lengths, or the other is I can make a short script for it. So obviously let's do the latter. This is my standard base code. If you have been watching my streams, you know it. There is no magic here. It's just I'll explain when I'll during the coding, I guess. So yeah, determine, I don't know if that's the correct spelling. Find buffer length. Okay. Now, perfect. Now it connects to the host, which is the service here, right? And now I need to do, well, I guess read this. I don't need this address yet, but I can read it. So, okay, I have a function called receive until a method actually, which receives all the data until a new line, because, well, we can see clearly there's a new line here, so I get the data. It's actually the address. I guess I'm going to convert it to int like this, but I'm not going to use it. Then it expects the data size, so it actually outputs this to me, like sends this to me. So I'm going to do another receive until, and I need to send it some data, so send all, and I need to send it some size. The size is what I need to check, so I'm going to take it as an argument here, and I need to send it with a new line, I guess, and here we go. And then it asks for the bytes of data, whatever bytes of data, and again I'm going to receive until this, and I'm going to send the given amount of data, which is again send all. And now receive until is actually my function, and it looks like this. It basically, while it doesn't find the text I have given it, it receives data. That's about it. It's really a simple function. Okay, so now I do send the bytes of data. I'm going to send A because, well, usually we send A's, right? And then I'm going to, I guess, look if there is a done or if there is no done. So I'm going to receive until done, and I need to check, like, if red is, if it's actually false, yeah, this is actually this method. If it's false, it calls this function, but there's a method wrapper on it. That means it wasn't okay, so it crashed. So if it's false, then return crash. Otherwise, return no crash. Perfect. And I need to do one more thing here. I need to close it, actually close my socket. I don't need this, and I can remove this. And now I obviously changed my method name to find buffer length, and I'm going to give it values from range. Well, I know already 128 bytes crashes it. I know 4 bytes don't crash it, so let's just start at 4, go to 128. And if it actually returns crash, then no, I'm going to do it like in a different way. Perfect. Print I ret, so we can see what's going on. And now I'm going to run it. So I'm going to run it actually from Windows. Yeah. No crash, no crash, no crash. Let's give it a sec. So the question feed is off because our service, which we, like a server which we usually use for questions, crashed for some reason. So, and I didn't get it up before the stream. I just noticed like when I started the stream, so apologies. Perfect. That's about it, I guess. 40 is the size of the buffer, probably because after it actually crashes. So yeah. We now know that the buffer size is 40. Perfect. So now we need to do the first thing which is described in the paper. The first thing described in the paper is finding a gadget which actually does something which you can notice. Now, so we already have 2 signals, right? I already used 2 signals here. I used crash when it did disconnect before sending the done message, right? If it sent the done message, then this actually would contain something done, and it would return no crash. Otherwise, it would be equal to false, and it would say crash. So I already have 2 signals. Now I need a third signal, which I can I can use later because, well, the crash signal, it will crash almost all the time, so it's not really a good signal. what I need to do is I need to find, for example, printing a different string, or like an infinite loop of some kind, so that it actually, you know, well, timeouts. So, okay, how to find, well, I already have the address, right? I have the address of it, so I already know that the binary begins at 4000000, obviously. So I can start from there, override the return address. I'm pretty sure the return address is, well, it might be just after the buffer, it might be like, it might be here. Well, actually with 8. Or it might be below it, but it will be close, right? It doesn't matter for now. And I can just scan, I can just put the different return values there. So I'm going to copy paste this function. I'm going to call it now in a different way. I'm going to call it find stop gadget, or signal. I think they call it the stop gadget or something like, the inf gadget in, well, there in the paper. And this is going to be the offset. Now I do get the address, and I guess I'm going to increase the offset by address. And now I am going to send a payload. Now my payload is made of 40 A's, that's the first thing, and the second is actually made of the return addresses which I scan for, right? And I'm going to scan using DQ. Well, I'm going to put it the address using DQ. DQ is just, you know, like your standard, yeah, this, like put an 8-byte long unsigned integer there. And my apologies, it's here. Perfect. So I'm going to put the offset here. Well, actually, I don't like this time. I'm going to put the offset address plus offset. Yeah, perfect. Times 8, because I don't really know if the return address is just after it, or maybe it's like, you know, 8 bytes later. I don't know. I'm doing it blind, right? Okay, and now I need to do one more thing. When I do this before, oh, I need to obviously send, well, as z as in size is equal to the payload size. And here I send the payload. And at this moment, I actually should do set time out to something sane, which is, for example, 2 seconds. And I wait until done, and I am actually going to change the way I use it, because the wrapper is actually a convenience wrapper. It's some modification I did really recently. Like, this is just a convenience wrapper. It either returns the text or false. Now, this method actually itself, sorry, this function actually itself returns one of the 4 values, which is okay, and the data, error, and whatever data it did receive, timeout, and whatever data it did receive, or disconnected, and whatever data it did manage to receive. And I'm actually quite interested in all of them, so I'm going to use this method, and I'm going to do this. So first of all, if error is equal to okay, I totally don't care. It finished, but it's not the gadget I'm looking for. It might be a signal though, but it finished okay, but no. It's quite improbable, by the way. I would have to really find the place where the function is called. So I'm going to return false. Now, if... actually, I'm going to do some list. False. If it's equal to timeout, or it's equal to... no, if it's equal to timeout, or it's... yeah, if it's equal to timeout, then I'm going to return true, which is, you know, timeout. Or actually, you know what? I'm going to just return error, right? Yeah. Okay, if it's crash, then it somewhat depends, but I will add some logic here, so it's not that I'm, you know, just returning the same thing all over again. Now there is one thing I mentioned is that it can time out, and that's a really good signal. Or the other signal which might work for me, it's actually some data was printed, but that was actually a different data than the echo something, whatever I have given it, right? Therefore, what I need to do is I need to check what was returned, but whatever was returned is actually going to also contain the echo, yeah, basically this, right? Echo, then my payload, and I don't really care about all that. Therefore, I need to skip it, so I'm going to do, well, maybe not that byte array, a list. Okay, then payload, which is actually echo, this, and yes, and then plus payload, whatever payload was there. And I'm going to do something nasty, which is while len of TheFatRat is not equal 0, then and actually TheFatRat of 0 is equal to payload, so the prefixes are the same. It's basically I'm writing a remove prefix. I don't know if in Python you can do it in an easier way, but remove the common prefix actually, yeah. Because, you know, if my payload contains like a \0 or something, and this is a C application, it probably might not display the whole payload. Therefore, I do need to do it this way. I'm writing code in the wrong function. I am perfect. Thank you very much for correcting me. I do need to move it. Well, I guess I already changed this function this much, so I am going to grab this whole thing and just move it here. Is it here? No, no, no. Here, here. Yeah. And I'm going to move this there. Thank you for telling me it. I would have a fun time debugging it. No, I wouldn't have a fun time debugging it. Perfect. Now, okay, blah blah blah. Done. Okay, I don't use this one. Although I do need. Crap. Sorry, just some cleaning. This is here. Okay, and let's go back here. Yeah, now it should be fine. Okay, perfect. So yeah, so I just drop top 0, just drop the first element from both. And whatever I get is actually like red is going to be equal to whatever I get. It's a list, so I do need to do this. It might be nothing, for example. That would make some more sense. Okay, if it's an okay run, then I guess I don't really care, so I'm going to return false. If it times out, then that's fine. If it crashes, then this is also fine. Yeah, otherwise also return false, because is there any other? Oh, it's an error. Yeah, I guess that's fine. If it crashes and len of red is actually more than 0, then I'm really interested, really curious in it. Okay, perfect. Otherwise, yeah, return false. That now makes a lot of sense. So I'm going to scan for some stuff, and I'm going to look for the gadget, which either times out, which means it executes more than for 2 seconds. I am going to increase this time later on. Or it crashes, which means it crashes and it has some interesting text for me, which is non-standard, because those two I can use as signals. Now I have no idea what size the binary is. I'm going to assume it's 4 megabytes, because why not? And I guess I'm going to use this one, find signal gadget. Now, if red is false, I guess I can just print it here. If it's false, then just is false, obviously, because this is Python. Continue. Otherwise, nothing. Yeah, Oh no, let's do it like this. Otherwise, actually print it. And here, let's do sys standard output write dot, so we can see it's actually working, and flash, so we can see it's actually working. Yeah, perfect. Let's see how if it works. Okay, something worked, but probably not the way I intended. Okay, I forgot to list here, so my bad. I don't believe it timed out. I have something wrong in my code. It would be too easy, and it's usually not. Maybe I should undo this before sending the payload. What am I doing wrong? I'm going to check if the service is still online, because in all honesty, maybe I'm sending the data incorrectly, and then it still waits for the data. I am sending the payload. Maybe the payload is too small. No, it's the length of the payload. And so print. This looks fine. I do have 40 A's. I do have this plus address. I could, yeah. Let's check this. Oh, I know. I need to check. Well, I don't know what's the problem. I just need to do this. Okay. Now I guess the question is, why doesn't it... So it gets to here, right? And it gets here rather fast. Okay, and then it really times out. Which is quite amazing. But I certainly do not believe that that's the case. Or maybe I'll let it run, let's see. And I'm going to answer the questions, and then I'm going to debug it. Maybe we have like we are lucky and we have a signal at the beginning. This should be removed as well. Did I forget \n? I'm not sure I forgot it actually. I was thinking about it here, right? But I'm not sure. If I give them the amount of data I'm actually going to transfer, then this should be fine. What's my size, by the way? 104. No, I edited it, and it's fine. It should crash probably. Maybe my connection got somewhat bad. Let's see. No. Okay, so okay. Again, I'm going to go back to the idea of actually letting it run for a second. It doesn't write done when you overflow the buffer. Yes, I know that, but it will close the connection if it crashes, or it will time out if it will go into an infinite loop. So that should be fine. Okay, quickly through the questions. Why do you not make just a library out of my pawn base? I just prefer it this way. This looks more like a side channel attack variation. Yes and no. I guess you also use timings, but I'm not sure that's a real side channel, in all honesty. Okay. Yeah, I think that's... so it doesn't time out all the time, it just times out on the sum functions, which is quite interesting. But why do I even get this data size thing? I shouldn't get it. I should have removed it from the data stream somewhere here. Why isn't it removed? I must have a mistake somewhere. I do connect, then I grab everything, I grab the address. I know the address is actually correct, right? And then okay. Then I get data size. I'm going to check if I receive it correctly. It does seem to behave rather fine, as in it times outs only sometimes. So I'm going to break it. I'm going to see if I do receive the data size. I do receive the data size correctly. Why do I have it again? I guess I'm going to print my my address and offset here. Oh, I know my mistake. Maybe not, but maybe that's not a mistake. Maybe that's a lucky thing instead of a mistake. So the address which I'm getting here is actually, you know, with a CAD at the beginning. And what I wanted to do is I actually wanted to do like grab, yeah, like 0, just 0 the bottom 12 bits. So I can start from the beginning. But maybe I just got lucky, and from the CAD, like there's an infinite loop right there, just waiting for me. I don't know. If that's the case, that's actually really awesome, and we just got really lucky. Let's see how it behaves if I do remove it. Therefore, what I need to do is I need to make a notes file. Yeah, I guess my mistake was that I was thinking I was doing something else than I was actually doing. Yeah, okay. Yeah, because at the beginning there's, you know, the elf header, and that shouldn't... well, it should be executable, I guess, because of the way the code is structured, but there should be no infinite loops there. I'm going to let it... No, I'm not going to let it run for a second. I'm going to do two things. First of all, I'm going to make a threading variation of it. You see how long it takes to actually check each address, right? It takes about 1 second, which means that we have a file which is 1 megabyte, and we want to scan, like, I don't know, just like 60K of it. We would have to wait 2 days. That's not fast enough for me, so I'm going to do this multi-threaded in a multi-threaded way. So I need to, I guess, create a global iterator. So let's go to it iter and this. I am going to need this threading anyway later, and I do need to create some kind of a lock. So lock is equal to threading.lock, I guess. Is it called lock or is it called mutex? I don't know. Get next with lock. It acquires the lock. Just get like next of the iterator, and yeah, and return. That's it. Okay, then I do need this in a function. Okay. Perfect. Now I do need to put this and like use the iterator, but it's not an iterator anymore. So while true, I equals get next. Get next is thread save because it has a lock. And it does all of this nice stuff, which is perfect. And now I can do threading thread target equals scan for gadget, which will give me a handle, but I need to start it. And I need to, I guess, create, let's say, 20 threads so it goes a little faster. Yeah. Now we have it multi-threaded. I actually, have this connection localhost since this the service is running on my VM. You might be able to use 20 threads on your machine, or you might, like on your case, if you're exploiting this or not. I don't know. Okay, I'm going to make this window a little thinner, I guess. I probably jump in main. Yeah, that might be the case. That's why I think we got lucky. If the CAD address is actually of main, and it gets back into reading my data. That's why it says, yeah, oh, this is actually even more lucky, I think. We got like super lucky probably, because as you can see, this value actually changes. So this isn't like a static print, it's probably some like print with some, or sprint maybe into a buffer, a print with some value, like with formatting, for example, x, right? %x. And we might be able to use it. So let's remember this. Let's remember this addresses. I'm actually going to copy them. Okay, but threading seems to work. I'm going to, I guess, knowing already that we have good signal gadgets there, I'm going to break this, and I'm going to actually scan from this address. Now knowing that I'm actually scanning from this address. Where is my, here we go. I'm not going to scan from this address itself. I am going to scan from, let's say, like COO. If there is any interesting stuff before it, I would like to know about it as well. And now I'm going to run it again. I hope I didn't mess up the thread. Now it works. No, it's okay. Yeah, it probably is main. It like displayed data size here, then the address. Alright, so that's good. Now I am still going to wait for an... Am I going to wait? I could wait for another gadget. Let's let it run. I'm going to run some code, but I'm going to let this thing run. And I'm going to run some code which abuses this, basically. Because we already found something which is outputting a number, which makes this really, really easy. Probably easier than you normally get in Blind ROP. Now, the next step is actually finding a gadget like pop RSI, pop RDI, and, well, actually in this order, right? Because we will need to be able to set these registers in order to be able to leak the binary, because again, our main goal here is to be able to leak the binary. Now, this is actually described in the paper how to do it, and they have a really cool idea, which is assume you already have these gadgets, and act as you'd already have them. Now, to do this, I am going to use this thing. Because I know that at this address, right, I get outputted this number. But this number isn't the same as this number, which means that there is some code probably there, again, like this. Well, that's probably like more like 16x and some address. And there's like also \n, maybe there's like data size, something, but I don't know, but I don't care about that. I care about this only. Now, and this runs correctly because the address given here is actually like something like this. But then it displays another address, and why could it display another address if it's run? I just jump a few instructors further. That means that this, which probably looks something like push this value, then push the offset of this string, and then actually like call printf, right? It means that I'm probably jumping here, which means that, well, it's not really push, right? Because we are talking about RSA and LIA RDA. Yeah, because it's 64-bit Linux calling convention. So I just omit this and I jump here, which means that if I do find a gadget which sets RSA, right, it will output a number controlled by me. So what I can do is I can actually jump, and this is by way of address. Yeah. Why didn't I copy paste the whole thing? Okay. This is the lowest address. Yes, it's the lowest address. Perfect. So yeah, so what I can do is I can jump into, like, put on the stack, right? Overflow the buffer and override the return address with some scanned value. Then I can assume, I need to assume that this actually hit a gadget like this. Pop, RSI, and then red. Or something equivalent. It doesn't matter what the gadget is, but it has to act like this. And then I'm going to put the value, like a special value that I want to put in RSI. I'm going to put like 41, 41, 41, 41, 41, blah, 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 like a 64-bit value. Just to be sure I get a 64-bit. That's too much. Is it correct now? No, it's too little. Perfect. So I'm going to put this value, and then I'm going to jump into print. Now a couple of things can happen. First of all, I can, with the scanning value, I can hit something which crashes the application. So I know there will be a crash, right? And if I get the crash, then I guess, like, try harder, right? Try again, right? Then it can actually not crash. This can not crash. It can do something, but not crash. And can print a number. But the number printed could be something different. So it prints a number, but like different. Then try harder. It's actually quite an interesting signal, because this already tells me that I did encounter something like pop, R, and some other register. I have no idea what, but some other register and red, or an equivalent gadget. I mean something which actually pops one thing from the stack and then returns. But it's not pop RSI, I know already that. If it prints actually like 41414141, it tells me that I got pop RSI, assuming that, and like again, I'm making the assumption that this understanding is correct. For all I know, it can be sprintf into a buffer, and then the format, and then the argument, which would actually put this, like this, in a different argument. It could be RCX, or like whatever else, or R8, I don't remember. That doesn't matter. I don't know, but I have to assume something, and I'm going to assume this for start, and I'm going to just check it. So these are the three signals I am going to look for. Now, what happened to this? It did find a timeout here, which... And there's a timeout here as well, so I have some infinite signals as well, infinite loop signals if I need them. Perfect. So, let's continue. Then I'm going to... I guess I don't need this to be running anymore. I mean, given that I already have this, I don't care. So, I need to make another function, and I need to make sure I don't write an incorrect function again. I guess that's one way to do it. And so I already have the signal gadget, right? And I know that my signal is actually a printf. And now I'm going to find the, like, find gadget, I guess. This is the offset which I want to scan. And now my payload is going... one thing, before I get here, I'm going to change the number of threads to 1. I'm going to change the scan address to always be equal to this. Yes, to this. So it outputs something. And I'm actually going to break here. And what I need to do is I need to find where the return address is, and this is going to be rather easy. I'm going to run it first. Wait, what are we doing? Signal gadget. Okay. Oh, because yeah, because it's false. So yes, I'm going to break here. It hardly matters, but I am going to print thread here. Okay. So now I run it and nothing happened. Why? Oh, I know. Because I do add the address there, so I just need the offset. And yeah, it printed the it printed this, which means that, obviously it was exploited. Now I am going to decrease it to 4, and let's see if it still does it. Then 2. Am I changing the correct function now? No, I'm not, obviously. Why would I? Yeah, again, 4. Two. And 1. Okay, it's still here, so we still can assume that the return address is just after the 40-byte buffer. So it's fine. I know I can use 1 here, so I can use 1 here as well. Perfect. Now I can continue what I was doing, which again would be making my payload. Now this, I can put the address of like, okay, so now let's take this. So again, at the end, I need to jump into this, into lia, like load effective address RDI, blah blah blah, and call printf gadget, which is here. And before that, I need to, this is the probable like scanned pop RSA pop actually something then red address, and then I need this value, which might crash the application in case it does something funny with it, but if it's just like pop red, it won't want to do anything funny with it. It would just like be acting normally. So yeah, so this is correct-ish, I think. And now I'm going to change this logic a little. Or am I? Maybe I'm just going to leave it. Yeah, I think I'm going to leave it. Though timeout is no longer interesting for me, so I'm going to make it false if it times out, but I'm going to also decrease the timeout to 2 maybe seconds so it doesn't stop me. If your internet connection would be slow and you're exploiting this, then your timeout would have to be lowered as well. Sorry, increased as well. Perfect. Now, okay. Now we can change this, scan for signal gadget. I'm not going to remove it, I'm just going to change it. Scan for gadget, then here I'm going to start scanning from, I guess, 0, because why not? Or actually, I don't know, maybe there are better gadgets near the main function, I don't know. 20 threads is fine. Then I'm not going to break here anymore. If return false, then go away. Print this. If, okay, now it looks fine. I'm going to run it. Okay, and again, what it should give me, it should give me an address of all the gadgets which actually are in this form. Because in that case it won't crash, it will output a number. However, I am going to node these addresses. I am going to look for addresses which actually contain this number. Because that means that's probably set RSI, assuming my understanding is correct. We should give it a go, so if you have any questions, then yeah, let me know. And I'm going, well, it will require probably some time. I guess this, like, if the binary is huge, then scanning for it is not the fastest, especially the way I do it. That being said, if you read the paper, then actually they have some optimization techniques on how to make the scanning more efficient, more, well, faster. Oh wait, Vesim has a good comment, but it's actually returning timeout. True. My bad. Correctly. Well caught, well caught. We could have been waiting here for a long time. But I will require some input from you. Yeah, perfect. Let's restart. You know what? This change, I'm going to remove it. Okay, data size, it's just printing different stuff, so that's not really interesting for me. And that's true, if we look at the how the program works, it first outputs the address, and only after that it actually outputs the well, it outputs whatever else, right? Which means whatever else isn't exactly precise. It then asks us for the data size and so on, so it actually waits for input. And that's where the timeout comes from. So Vesim, points for you again. Thank you for noticing it. And thank you to KrzaQ for letting me know. KrzaQ is our moderator today. If you have any questions, do ping him. As you can see, there are already some places where it just outputs the same old number we already saw, but which don't crash, which probably mean that there is some other pop, like pop with a register, but it's not RSI, it's some other register. That might be useful later on, so I am going to, when this finishes scanning and finds what I need, I am going to note down these addresses. Because like later on we can just, we don't have to really scan through everything, we can just scan through these addresses when we will be looking for what? Looking for pop RDI, because we will have to find it as well. It's quite interesting because, like, for example, here we already know that there is a gadget here which just zeros RSI, right? But that's not what we are looking for. So, okay, let me tell you, I am going to let it run for a sec, and I'll tell you my plan how to find RDI. Now, if we look again on this, right, how the communication goes, there is a done print here. And I probably already have this done print somewhere in my notes. I don't, but it should be somewhere close. Maybe it's somewhere here. Oh, because it doesn't time out, it probably just crashes. Yeah, but there, and we will find whatever prints this done, or maybe, yeah, but I think that's the same idea, because my suspicion here is that this done is just printed by puts. Because if we print, for example, like, or maybe this data size, this could be printed by puts as well. So, and I think we actually did find already the data size, right? We have quite a lot. Yeah, here, for example. Which means, oh, there's this like, oh, but this new line is actually from our own data, probably, like echoed or something. Anyway, the difference is that it actually gets the argument, gets the argument in RDI register, and we are going to probably need the RDI register as well. So the way I'm going to do it is I'm going to call it with a known address that contains a known string. Now, how do I get a known address which contains a known string, you ask? That's actually easy. I mean, I know already where the binary is placed, right? I know that the binary is placed at the address of 40000, well, which means that at exactly this address +1, there is the string elf. So I'm going to set like the value, which is 41414141 now for us, to this address +1. I am going to set the address of print to be basically the address of that puts, of data size puts, right? But a couple of instructions further, because again, the first instruction before the call is actually setting the register, and we want to skip that. And then I'm going to scan basically for an instruction which ends up printing elf. And when I have this, I can actually dump the binary already. So that will be pretty easy. I guess I don't even need to find RSI in that scenario, but I'm just going to let it finish, I guess. You can see that there are like some other settings for RSI register that I encounter during the search. So, okay, I guess I can just code it executive. But before I code it, I actually need to figure out how many bytes is this instruction. So to figure it out, I'm going to create a small assembly snippet. No, I'm not going to create a small assembly snippet, or am I? No, I am. My bad. I wanted to use the Godbolt compiler, but it actually shows assembly, not bytecode, and I need bytecode for this. So test asm is going to be an asm6, sorry, it's NetWise assembler, obviously, bit 64, and the RSI, and then some address, I don't know. Well, the addresses are all in this form, probably, I guess. And then, like, just a knob. I just want to see how large this instruction is. Hmm. Test. Okay, so this is quite a huge instruction, but you know what? Actually, it could be a different thing. It could be encoded like this, but it's something, but it's relative. So I think it's like you write something like this in ASM. No, how do you write relative addressing in ASM? At least forget it. Where's this? I know it's rel. Relative addressing, rip plus or rel symbol. Okay. So rel is actually inside the brackets. Here we go. Absolute address cannot be used. Okay, whatever. I don't care. And it's also shorter, so it's 7 bytes. So that tells me something. So it's like this is 7 bytes, probably, or it's in the other case, it's 8 bytes. Alright, okay. Perfect. Now I could use, I guess, the print I already have, but I'm a little worried that the formatting will not really be... I guess I can do it in 2 steps. I can first use the print, which I already have, and then use the... when I find the elf, sorry, when I find the pop RDI, I could look for the puts gadget instead. That makes a lot of sense, I guess, to do it like this. Because guessing where the puts is located is just guessing. How's it going here? I don't know. We have a different value here. But we are still missing the for one. Off topic, what t-shirt are you wearing? And what is Roots Conference? I don't know what's Roots Conference. The t-shirt is this one. And it's not Mood, it's Doom actually, but you know, my camera is reversed. Mood would be a really interesting game though. Really dark and gloomy. Oh wait, the Doom is that already. Never mind. Okay, so, well, knowing this, I guess I can start coding. Maybe this will find my gadget sooner or later. Can close this, so... sort of waiting. No, for one, no. Okay, that's not good. Okay, so I am going to comment this out, I guess, and I'm going to comment this out as well. I'm just going to copy this. Okay, so first of all, the first one is okay, and anything interesting? No, for once, maybe be above. I missed something, which was for one. No. Okay. Oh. I can have hope, right? Oh, I'm in the. Oh, okay. TheFatRat's conference. Sorry, I totally. I didn't know it was called like that. Like, I was asked to be in a member of a panel board. I was like last year as well, but on a different conference, and for some reason I was remembering different conference but organized by similar people, and I was like confusing the two for some reason. Well, yeah, there you have it basically. I know that like Sergey Bratus is responsible somewhat for, I don't know, maybe the panel, or he is on the panel basically. If you don't know him, just Google him basically. But yeah, that's all I can say. I didn't review the papers yet, so I don't know even the papers, what kind of papers will be submitted. So I cannot tell you too much. I'm sorry. I know I'm terrible, sorry. Okay, let's get back to this. The address of elf +1, which is this, which is fine, and then I'm going to +7 this to jump over the Lia. I think it might be 7, it might be something else, I don't know. Let's just assume this. And I'm tempted to let it run for a few more minutes. Oh, perfect, we got it. Here we go. Yes. This too. Okay, I'm going to copy both to my notes. So we have something going for us, and that's like, we already know that at this address we have a pop RSE red, or something similar, because you know it could be like a huge function which just goes through and in the end does the side effect of it is this. So yeah, perfect. So we have this gadget, now I need the second one. I already have this coded. I guess I'm going to look around in the similar proximity. I mean, this kind of gadgets tend to be, you know, there tends to be a series of ROPs, like pops, near one another. So I guess I'm going to look from 3000, starting at 3000. 3000. Okay, perfect. And I'm going to double check this just to be sure. The scanned address, which might be pop and hopefully RDI. Then the address of the elf. And then what I hope to be... There's a lot of assumptions here, but let's see. I have a question about browser fuzzing. How is that accomplished? What do I need to target? Yeah, that's a... Oh, it something works at least, so that's not bad. That's actually an interesting target, I guess, because, well, there are a couple of ways to do it. One way to do it is, because like browser is actually a huge thing, it's like an operating size thing. I mean, you know, there are threads, there is different tabs and so on, so there's process management and so on. So it's basically like an operating system. So there are a lot of things you could target. You could target, for example, the network protocols, which means you could fuzz the network protocols. You could target the image parsing, for example, but that is the most popular target, or was the most popular target. Then you could target, I guess, DOM or JavaScript. For example, one of the ways to do it is get a list of JavaScript functions and call them with random arguments, the more the arguments make sense, the better, and fast like that. Or you could grab, create a DOM tree and then do some JavaScript operations on the DOM tree, like adding, removing, and maybe some use after free, or like some reference would be left somewhere there. So yeah, I guess these are like approaches. You can look, for example, at crossfuzz, like CROSS fuzz by El Kamtaf. That was a pretty neat browser fuzzer, I guess. What's your exterm font? My exterm font is actually the default one. I have absolutely no idea, but it's really the default one. I think it's the default one. Can I check it here somewhere? No, I don't see it. Okay, I'm not sure if this is actually working, to be honest, because on the other hand, I'm not sure it's not working either. I might have gotten the address wrong. Times out from time to time. Doesn't tell me too much. Let's give it a few more seconds, I guess. Okay, so once we find it, assuming that my hack actually worked, once we find it, the next step is to, well, if we can print like elf, we can print whatever part of the binary, so just going chunk by chunk and printing the binary, so that would be the next step. Yeah, seriously, I'm not sure it's working. Therefore, what I should probably do at this point, is to look for a different gadget, I guess. Oh, I know. I should probably look for try to return to the done gadget. I'm going to do a copy paste of my code. Oh, it's not here. Okay, and yeah, I'm going to break it. I'm not sure if it's actually looking in the right places. So probably this might be incorrect. Yeah, or maybe I should scan in a different region. Maybe I should scan from the beginning after all. I'm going to assume this was incorrect. I'm going to put 6 here. Let's see. Let's see if this gives me anything, or maybe it should be 8 after all. So let's put, no, let's start with 6. This might totally backfire. I think 8, there's at least some reason why 8 could be called here. Yeah, maybe. Yeah, let's start with 8 and let's see what happens. And I'm going to change the code while it's scanning. It's scanning from 0 now, perfect. So okay, what I need to do now is, am I running the correct function? Obviously not. How did I even find? No, I am running the correct function, never mind. Okay, so let's change it a little, and yeah, let's just like, after the buffer at payload dq, and no, that's not correct, this is correct. Okay, so the return address, but I am going to do more thing here. Mainly, if this actually returns done, then I'm in the right place. So if done in red, then return error. Red. Yeah. Okay, doesn't seem to be any lag there. I already know I'm going to use the same like scanning range as I did there, which means I'm going to scan from x0. Yeah, because you know probably the main is located somewhere there. Let's see. Okay, I'm looking for done. And it's not going to be a timeout, it's going to be probably like an OK with an exit. It's quite funny how race condition actually mixes the strings. And what? I went through the whole function without finding it. Oh, because it might be actually in another function, right? So I'm going to, you know, because the function might be before it, so I'm going to increase the scan range. I'm going to increase it by changing this to 8, for example. Well, maybe not 8, that's yeah, B. Let's try B. Okay, there's a question, thankfully. What do I think about using IA in cybersecurity? So is that AI? Or is IA for something? What does IA stand for? IA, okay, AI. Well, it's a good question. I don't think there is much use for AI in cybersecurity yet. But yeah, maybe. I guess. Yeah, I didn't yet hear about a good usage of AI in security, but let's see what happens. I mean, AI has been developing for quite some time now and going like really moving forward. So yeah. What is your opinion on beginners using pawn tools? Totally, go for it. I mean, I wouldn't expect a beginner to write their own library, right? Because why would you? So this isn't working too well. I'm going to break it. And what else can I do here? Maybe my code here is somewhat incorrect. Because there is no... I'm going to print red just in case I'm not messing anything up. I'm pretty sure I am messing something up. Oh, I know. Maybe if error is like equals okay, then actually like return. Yeah, let's try it again. So it seems to be the place where like the main function or the function above it is located. It's a lot of waiting, isn't it? I guess the stream should be somewhat finite, so I might actually cheat a little and look at my attempts from the morning where I actually did find the gadget. And let's speed it up, I guess. So my notes from the morning, what do they say? Actually, it's not really notes, it's a dump I made in the morning. Like, here we go. Okay. So, well, it seems to find the gadget which I was looking for at around this location, and which was the pop RDA. And let me look at the address which I was using. Here we go. That's from my morning attempt, where I actually did get the binary dump. And I was using set RDI, then the offset, and then puts. Now what's puts in this case? Puts is equal to the second address, which is this, which is CBB plus 1. So I guess I'm going to just use it for demonstration purposes. Yeah, in the morning and in the evening it took me hours to actually make a proper dump. So I wasn't really expecting to get it right on the stream. But let's get this moving a little. Perfect, so let's jump back here. And instead of this, I was using CB plus 7 plus 1 for some reason. And I knew that was puts. I did have this, and I did... Let's scan it for it again. So the address is there, my scanning region is going to be from 0. Or maybe just to make sure it works from 5. And I'm going to look for, this time not for this or not for the other, I'm going to look for elf. So if it's okay, then no, return. If timeout or crash and length, return. Perfect. Yeah, so it wasn't about this part, it was about this part. If it doesn't work, then it means I have something in my logic incorrect, which I guess I can start reviewing now. So let's start with what am I doing here. I'm pushing the scanned offset, which is correct. Then I'm putting this address I do believe is correct. And this should set like pop RDI, and then it should call puts, which should again output some data. Now, if I do go down here, what it does, it actually... what does it do? Okay, this times out, but it didn't find the same gadgets, which is quite curious, isn't it? Okay, I'm going to stop it. Why don't you find the gadgets which I could find in the morning? This is correct, I guess. 212B was the offset I was using for this. No. Yeah. Or wait, maybe I'm reading it incorrectly. Let's try it again. Okay, threaded, then I dump actually, and this is puts, and this is the gadget. Oh, wait, the gadget is actually in a different place than I thought. So maybe it does work. Yeah, I'll give it another go. If it doesn't work, then I guess I'm going to write a blog post on why it didn't work. Yeah, I guess if you have any questions at this point, then let me know. and otherwise we should be finishing the stream, like unsuccessfully this time. Though, I guess to cover what did happen was that I did find correctly the RSI, pop RSI instruction. I was not able to find the RDI instruction due to some reason. And there's probably a bug in my code which prevents me from finding it, because I don't think it's anything else. Yeah, it should have already found it. Okay, I'm going to write a blog post then on my blog about why it failed, just to document failure. If you have any questions, then yeah, feel free to ask now, otherwise we will be finishing the stream. And the next topic is going to be on... there's going to be a wargame challenge I will be doing next week. And the wargame challenge is going to be about... the idea I basically have is to go and ask around some websites which specialize in wargame challenges, and ask them if I could just, you know, make a video or like a live stream about solving 1 or 3 challenges from their site. And yeah, I guess I was asked about doing some more web challenges this time, so I guess I could do a web challenge next week. So yeah, let's settle on that. Will I be going to DEF CON this year? No, I'm skipping since the... well, our team didn't qualify for DEF CON this year, so I have an excuse not to go to Vegas this year. I think I went to Vegas like 3 years in a row or something. And, you know, Vegas is cool and everything, but it's not a place which... It's a cool place to visit once in your lifetime. Which distro did you use while playing CTFs? Windows, the best distro, and Ubuntu? Like both, actually. As you can see, I have like one console in Windows running, but in my other Windows I have a Linux console, so I did comment on my setup several times. I'm curious what the hell, but probably the mistake is like really trivial. Yeah. Any good resource about learning WinDBG? I'm sorry, I don't really have anything. For WinDBG, I'm not an... Well, you saw me trying to do a crack me at a couple of streams ago, right? About, well, on using WinDBG, and it was a really simple crack me, and it still took me a while. So I'm not really familiar with WinDBG. I know there's a book about it, I even have it, but that's about it. So maybe someone else on the chat could recommend some learning resources for WinDbg. Okay, does the ASLR have any impact on finding the gadget? So ASLR in this case is actually disabled, which means it shouldn't affect it. Maybe I can do pwnable.kr. I think I have one already where I have permission from the authors to actually do it, and I don't think it's pwnable.kr. Yeah, it's not this one. Maybe I can ask about it later on. In all honesty, I don't remember which site I haven't noted though. Any good resources about exploiting use after free? No. I guess the problem with asking me for resources is that I don't really keep a list, and I usually just Google stuff. So yeah. Oh, there's Derbesser Visor says that Life Overflow did a video on use after free, I guess. That's a good recommendation. Okay, cool. So let's round it up for today. My apologies for it not working, but well, I'm not super surprised. You know, it's easier to do something offline. And again, it's like the second time I was approaching this. I will write a blog post on what was the problem. The problem is probably going to be trivial. And yeah, and see you next week then. So thank you for being here, and I leave you with mission number 8. Good luck with solving it. It's actually easy this time. And yeah, happy hiking and see you next time. Bye bye. And thank you, KrzaQ, for being my moderator as always.
Summer in the hills, those hazy days I do remember. We were running still, had the whole world at our feet, watching seasons change.